When we're looking at expanding things. Mick, what do I mean when I'm expanding things? Yeah, right. I guess like when we think about it in terms of a word definition, expanding, we're thinking about making things bigger, right? Mathematically speaking, anytime you see expand, this is what I want you to think about. There's going to be brackets involved, and everything, we want to multiply everything on the inside by the outside, okay? That's really what you want to think about when we're looking at expanding. If you have brackets involved, you want to multiply everything on the inside by the outside. Now, we are going to learn some tips to help us do that, but that's the basic premise when we're looking at expanding. Simplifying, again, slightly different, but we use this word simplifying a lot. The definition I want you to use for simplifying really is, in this case, it's going to be looking at gathering like terms, okay? So whatever you wrote there as well, making a little note, I also want to gather like terms, okay? I am introducing a new topic though, right? Binomial expansions. And Chloe had a really good question. What does it mean when I'm looking at something, like what is a binomial, right? Well, it's a great question. Just look at this first prefix here. Bi, right? When we're thinking about bi, we're thinking about two things, right? You know, biceps. I don't have many. That's okay. Biceps, two muscles. Bilingual. I am bilingual. I can speak two languages. Bicycle. Yeah, there's a whole heap of things like that, right? So whenever you think about binomial expansions, just think about having two terms, right? In this case, we actually have two pairs of binomials, right? They're both multiplied together. But anything with two terms really is a binomial, right? You could have like, in those previous examples, you know, x squared plus 5x. You could have x plus 3. These are all examples of binomials. We just have two terms there, right? Well, the real question is, why do I care about binomials? Okay. In your recent assignment, you've been looking at trying to model real-life situations using mathematics. In particular, what did you actually look at in your assignment? Break even, right? The point where a company is not making money or losing money, there's a point, the break-even point, where the profit's equal to loss. Okay, and that helps us determine the prices of a product. What should I sell it at? How many do I need to sell? In your example here, in your equations, you would have only had linear equations. So that means there's no powers involved. There's only the powers of 1. But now we're starting to introduce squares and cubes, right? This changes our functions dramatically. If I punch in one of the equations that you had on your do now, 5x outside of 2 minus 3x, what kind of shape do we have now? We've got a curve, don't we? Does anyone know what this is called, actually? It's called a parabola, okay. And parabolas can be used to model real-life situations as well. How can they be used to do that? Well, everyone's favorite game, Angry Birds, right? We can model the Angry Birds shot using a parabolic kind of shape. Okay?
No one's favorite game.
Oh, okay, it's my favorite game. But obviously, Angry Birds is a kind of trivial application, right? That's not something that we would use every day. Something you do use every day is when you're watching television or when you're using your phones, right? When we look at satellite dishes, they're actually modeled after parabolic shapes. So the only way we can actually receive signals from space and communicate with each other is through use of these parabolic dishes, they're sometimes called, or satellite dishes. Okay, that's one way we can think about what the context of what we're learning here.